We have a question here where we have a cube, okay, and it has a volume of 1 centimeter squared. Oh, sorry, cubed. And the question here for part A is to try and find the expression of the volume of this cube with a side of x length. Cool. This one's going to be quite easy. It is a cube. That means that side's equal to the same, that side's equal to the same, and that side's equal to the same. And then just for context, if it's a cube with 1 centimeter cubed here, that means that is 1 centimeter, that is 1 centimeter, and then the height is 1 centimeter. So really easily, the volume with respect to x is equal to x times x times x, which is x to the power of 3. That's how you get 1 mark. Let's go on to part B. All right, so this is saying we have decreased the sides from 1 centimeter. So the cube went from being 1 centimeter on each side to now it is 9 millimeters. Okay, 9 millimeters in centimeters is 0.9 centimeters. So if you have 10 millimeters, that means that you have 1 centimeter. Okay, so it's asking us to estimate the decrease in volume. All right, so I'm not sure if you remember this, but this is the classic rule here. Let's say that the change in volume is approximately equal to the derivative of dv dx with respect to x there, and then times by the change in dx. So that's one way to write it. Another way is that you might see it written like this, that the volume is equal to dv dx, and then that there. So d is like really small. Okay, it's a like small change, and then this is like capital D in the Greek language, so you can say it's like a bigger change. So this is like the formula we're going to use here. First of all, we need to figure out this function here. What is that? And we can do that by differentiating. All right, so we can say that the differentiation of our previous value, which was x to the power of 3, remember this one? Well, that means it'll just be 3x and then 3 minus 1. So remember, we bring that 3 down towards the bottom there, and then we minus 1, and that finds the differential, the gradient of it. So it's 3x to the power of 2, okay? And so what we do is we substitute the value at that point. So it is at point 1, right? And that would be 3 times by 1 squared. So really easily that's 3. And then we have to figure out what our change is. Well, we went from 1 to minus 9, so that means that we've gone like this. So negative 0.1, and really simply, we can say that it is the estimated change is going to be equal to 3 times by 0.1, and so we can say that it's equal to minus 0.3. Now you've got your calculator, right? So you can do this very, very easily. But I'm just going to take you through step by step as the math isn't too difficult. So the next thing is that that's all we've really got to answer is what is the change in volume? And we're going to say in plain English, the volume has decreased by 0.3 centimeters cubed. And so really the hardest bit about this was remembering this particular equation here. Okay, and then remembering to substitute with the red bit, to substitute it at the point that you found originally, which is that 1 value. And then this delta bit is going to be that just negative 0.1. So you don't really need a calculator here, but it is a calculator question.